Hello everyone. In the previous class you had learnt how to write the structure of Lewis molecules. Lewis dot structure. In today's class we shall look into the drawbacks or limitations of octet rule. Now this octet rule means it should have 8 electrons in the outermost shell and the atom or the molecule becomes very stable. So what are its limitations? Now many atoms in molecules, they do not follow octet rule. It is not followed. Octet rule is not followed by many atoms in the molecules. And this octet rule is applicable for the atoms of second period only. So which are the elements of second period? Yes, lithium, beryllium and Beknoff, BCNOF, and followed by noble gas. So only second period elements, they obey octet rule. And noble gases like xenon and krypton, though they have octet, though they have 8 electrons in their outermost orbital, they still form compounds with oxygen and fluorine. So what I had said earlier, if they have 8 electrons in the outermost orbital, they should be stable. But xenon and krypton, though they have 8 electrons in the outermost shell, they still react with oxygen and fluorine. And octet rule does not explain the shapes of the covalent molecules. So with octet rule we cannot explain the shapes of the molecule. And this theory does not explain the relative stabilities of the molecules. It does not talk about the stabilities of the relative stabilities of the molecule. Then HCl, though it has 8 electrons, but still it is not stable. This cannot be explained by octet rule. So we shall look into some of the examples wherein octet rule is not followed. Now look here. We have hydrogen. What is the valency of hydrogen? Only 1. So hydrogen molecule is formed by sharing of only 2 electrons. 1 electron from each hydrogen atom. So hydrogen molecule does not obey octet rule, but still it is stable. Then coming to incomplete octet. Incomplete octet is shown by molecules like lithium hydride, beryllium hydride and boron trichloride. It is shown by the molecules having valency less than 4. So those molecules which have valency less than 4 or the elements which have valency less than 4, they show incomplete octet. Now coming to lithium hydride. What is the atomic number of lithium? 3. How many electrons are there in the outermost orbital? Only 1. Its valency is 1. So 1 electron of lithium takes 1 electron of hydrogen and forms a bond. But does it obeying octet here? No. So it is said to be incomplete octet. Beryllium valency is 2. It is forming beryllium hydride. Again there aren't any 8 electrons here. Therefore it is incomplete octet. Same is true with boron trichloride. Now boron valency is 3. Right? But it is not having 8 electrons. 1, 2, 3, 4, 5, 6. It is only having 6. But it should have had how many to become stable? 8. But it is not having. Therefore, it is showing incomplete octet. Now there are molecules which have odd number of electrons and they do not obey octet. For example, what is the valency of nitrogen? 5. So I have shown the valence electrons here. 1, 2, 3, 4, 5. Yes. And it is making bonds with oxygen here. But is nitrogen having 8? No. 1, 2, 3, 4 and only 5. Therefore, and moreover it is having 1 odd electron. Therefore it is not obeying octet and we say it is an odd electron molecule. Then coming to expanded octet. The elements beyond third period make use of 3s, 3p and 3d electrons also to form bond formation. So the elements from third period onwards, they have electrons present, they have more number of electrons. And these electrons are present where? In 3s, 3p and 3d orbitals. And these electrons Okay, the total valence electrons, it is more than 8, and such molecules are said to be in expanded octet or superoctet state. It means their molecule will have more than 8 electrons in their valence shell. So look here, I have phosphorus pentachloride. Now we shall just count the number of electrons in the molecule. How many it should be there? Totally 8. But how many are here? So 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore we say PCl5 has expanded octet. Same is true for SF6. So how many bonds are there? 6 bonds. 6 to the 12 electrons are involved in bonding. So expanded octet. And same holds good for H2SO4 also. Right? So there are many molecules which do not obey octet. And we call them as drawbacks of octet or limitations of octet. Under that we study, yes, odd electron and expanded octet molecules. Now we shall study another important aspect called as formal charges. Now the charges possessed by polyatomic ions like CO3 2-, SO4 2- are the net charges on the ion. The ion as a whole has a net charge. Okay? Are the net charges on the ion as a whole and not possessed by a particular atom. In CO3, how many atoms are there? 4 atoms. 3 oxygen and 1 carbon atom. Now what is the charge on carbon atom? We don't know. What is the charge on the 3 oxygen atoms? We don't know. As a whole, what is the charge on CO3? It is 2-. Understood? So the charges possessed by polyatomic ions are the net charges on the ion as a whole and not possessed by a particular atom. But is it possible for us to find out the charge on a particular atom? Yes, and that charge is called as formal charge. But it is possible to assign a charge to each atom in a polyatomic ion, and it is called as formal charge. And how it is calculated? It is calculated by the following formula. So formal charge is equal to number of valence electrons in free atom minus the total number of non-bonding electrons minus half of the total number of bonded electrons. Now we shall try to calculate the formal charge on ozone molecule. Now first we shall write the structure of ozone molecule. So what is the structure of ozone molecule? O3. So I shall write the structure of it, C double bond O, O. You should be able to write the structure of ozone molecule. Now I shall number them as 1, 2 and 3. So we will complete the octet structure of it, Lewis dot structure. What is the valency of oxygen? 6. When it is involved in bonding, together it will have how many electrons? 8. So we will check for oxygen number 1. How many electrons are involved in bonding? 1, 2, 3, 4, 5, 6. These are bond pairs and 1 is lone pair. So I have shown the lone pair here. Coming to oxygen number 3. How many are involved in bonding? 1, 2. How many more you need to make 8? 2, 3, 4, 5, 6, 7, 8. And how about this? How many are involved in bond pairs? Bond pairing. 1, 2, 3, 4 are involved. How many more I need to make 8? 4 more. So 4, 5, 6, 7, 8. Now what is the formula I had given? So before we go for that, we should know what is the valency of the oxygen atom. We know that valency of oxygen atom is equal to always 6. Yes? 1s2, 2s2, 2p4. Atomic number 8. Right? So valence shell is this one. How many electrons it has? 6. So in order to become stable, it wants to have 8 electrons and hence it is involved in bonding. And I have written the Lewis dot structure. Now what is the formula I had to calculate charge on each atom? So formal charge is equal to what? Valency, total valency of the atom minus number of electrons in lone pair minus half of the number of electrons in bond pair. Understood? So once again I shall write what is formal charge. Formal charge is equal to valence electrons, total valence electrons of the atom minus number of electrons in lone pair minus half of electrons in bond pair. So I shall take oxygen number 1. So this is our oxygen number 1. So what is the valency of oxygen? It is 6. Valency of the oxygen atom is always 6 minus number of electrons in lone pair. How many electrons are involved in lone pair here? Only 2. Right? And how many are involved in bond pair? 1, 2, 3, 4, 5, 6. So I shall substitute these values in the equation. So to valency of the electron is 6, valency of the atom is 6 minus number of electrons in lone pair. How many are there? 2 minus half of the electrons in bond pair. How many are there in the bond pair? These are called as bond pair. What are bond pair electrons? They are the electrons involved in bonding. Lone pair, they are not involved in bonding. It is alone. Okay, how many are involved in bond pairs? 1, 2, 3, 4, 5, 6 into 6. This comes out to be 6 minus 2 1s are 2 2s are 4, 2 3s are 6 minus 2 minus 3, that is equal to 6 minus 5, which is equal to plus 1. So what is the oxidation state of the first oxygen atom? It is plus 1. So we shall calculate for the second one on the same lines. So what is the total number of valence electrons for second? So formal charge of oxygen numbered as 2. Valency is 6. How many lone pairs are there? 1, 2, 3, 4. So I shall substitute 4 minus half of number of electrons involved in bond pair. How many? 1, 2, 3, 4. So into 4. 2 1s are 2 2s are 4. It will be 6 minus 4 minus 2, that is 6 minus 6, which is equal to 0. So the formal charge on the second oxygen atom is, understood? Okay. So total valence electron is 6 minus number of electrons in lone pair 4 minus half of number of electrons in bond pair, that is 4. So you get answer as 6 minus 6, it is equal to 0. So what is the formal charge on the second oxygen atom? It is 0. It does not carry any charge. So we shall calculate for the third one. Okay. So formal charge of oxygen numbered as 3. Total valence electrons 6 minus the number of electrons involved in lone pair. How many? 1, 2, 3, 4, 5 and 6. So 6 minus 6 minus half of involved in bond pairing. How many are involved? 2 into 2. Six minus 6 into half of into 2. So 2 1s are 2 1s are. This comes out to be 6 minus 1. This is 6 minus 7, which is equal to minus 1. So what is the formal charge on the oxygen numbered as third one? It is minus 1. So this part I hope you have understood, and it is very important from examination point of view, and it will be asked for 3 marks and for 1 mark in CET and NEET examination. So you should be perfect with this part. So once again I shall repeat, how do you calculate formal charge? Formal charge is equal to total valency minus number of electrons involved in lone pair minus half of the electrons involved in bond pair. Go on substituting the values. Hope you have understood. Thank you.